All right, double replacement reactions are when you have two compounds reacting and they trade cations with each other. So remember, the cation goes first, the anion goes second. There are a few different types of double replacement reactions. There are precipitation, where you form a solid product or precipitate. Neutralization, that's where you combine an acid and a base. And the third type is where you form a gas. Okay, so let's take a look at the first one, which is precipitation. Okay, in a precipitation reaction, you are forming a precipitate. Here is an example. Silver chloride is a solid, therefore this is a precipitation reaction. Neutralization reactions are where you combine an acid and a base and you form water and a salt. Let me know when I can move this down. Yeah. Okay. The one thing that we should highlight in here is that heat is often detected during neutralization reactions, albeit a very small amount. Okay. So that means that neutralization reactions would be exothermic. And then, can I move it down? Yeah? Okay, let's come down here. Notice they're showing you heat on the product side of this neutralization reaction. Here's your sulfuric acid combining with potassium hydroxide, which is your base, and then potassium sulfate is your salt, and then here is your water. Okay? Now, sometimes you're going to form an unstable product during a double replacement reaction. It is very important that you know what is unstable. So, the products that are not very stable and spontaneously decompose into water and a gas, the most common ones that you should know would be carbonic acid, which you guys saw in the lab. Carbonic acid is H2CO3. It is so unstable that it decomposes immediately into carbon dioxide and water. Ammonium hydroxide, which is NH4OH, also decomposes into ammonia gas and water. This will be smelly. It'll smell like cleaning products. Okay, you'll get a little whiff of it. I think that's really all that I need to highlight there. Let's take a look at the practice problems, and then we are done. Let's go right here. We're not going to do all of these. Let's take a look at number 1 and number 3, okay? For number 1, I strongly advise you write everything out in words. Although HCl is hydrochloric acid, I would not write it that way. I would write it as hydrogen chloride. And I would do this every single time you get an acid and you're trying to predict the products. Write it improperly because it will help you figure out what products you would have. And then I've got iron 3 hydroxide. So that means the hydrogen and the iron 3, make sure you leave the Roman numeral with the metal. They will switch places, and then you're going to form iron 3 chloride and hydrogen hydroxide. Okay, so this is going to be Fe plus 3 and Cl minus 1, so that's how you get FeCl3. And then hydrogen hydroxide is just water. It's HOH. You could also write H2O. That would be acceptable. I'm not going to balance it. I'm just going to leave it like that.
Sorry, I forgot my question.
Okay.
Oh, I just got it.
I'll come back to you. Number 3. For number 3, this is ammonium sulfide. And then we've got cesium hydroxide. Okay, so the cation in each, which is the first substance, they will switch places. When they switch places, I form cesium sulfide and ammonium hydroxide. Okay, cesium has a +1 charge, sulfide is -2, and then ammonium has a +1 charge, hydroxide is -1, so that's how you get NH4OH. I'm not going to balance that either. Okay, you get the idea. Yes.
Okay, I remember. Does
Okay.
activity matter for double replacement?
Does what?
Does
States that matter?
how active it is?
That's only for single replacement.
Okay.
Okay, so both number 1 and number 3 are double replacement, so you don't have to worry about that activity series, okay? Okay, any questions on that? Okay, so I'm gonna unlock this homework.